Hi, this is a 12 volt 10 amp SMPS by Metek. So now I will tear this down and we will test this. I'll remove the screws. Okay, so this is a cooling fan. It blows into this area from the transformer. So now let's see what's the layout is. So from this case markings, this seems to be live, and this is neutral, and this is earth, and these two are negative and these two are positive terminals. So from the looks, so before I already tested it, took this circuit and tested it. So this is how this circuit looks like. So live goes into this fuse. This is a fuse, and this is a Y class capacitor, and this is a common mode choke. So this basic filtering all happens here, mains, and then this is rectifier. This one switches from 220 volts to 120 volts, or if it depends upon the voltage you are plugging in this into. So if you are using a 240 volts or 220 volts outlet, you have to select this 220 volts. If you are if you are using 110 volts, you have to select this, but do not select 110 volts if you are using 220 volts, because this will get destroyed. So after that, these two are smoothing capacitors, high voltage smoothing capacitors, but these are not branded ones. This is a cheap knockoff. And this is a controller. This although I forgot the name, but I think it's a Fairchild 750 PD series. I will later in a next video I will completely analyze this circuit. So anyways, this is a PWM control that controls this switching transformer, and this is a smoothing network, an LC filter network. This is, and we get here the output in these four terminals, two positive and two negative. So that is how this circuit works. This is a fan controller, and here we have an anti-C. Based on the temperature, this will throttle. So yeah, so pretty simple circuit. If we can get this data sheet on this, it will be easier to analyze the circuit. In a next video I will probably analyze in detail about this. So we'll test this now. So according to the marking, this one is live. Now you please do not try this. You should never try something like this with exposed AC and everything. AC should never be exposed. If you by accidentally touch this, you will get shocked and it may even kill you. Okay, now I need something to power this. I'll be using a multimeter in ammeter mode to measure the current, and we'll be using this 10 ohm 25 watt as a load. positive. So positive comes into this resistor, and resistor is this other terminal goes to multimeter 10 amp jack, and 10 amp common jack goes into negative terminal. Once again reminder, please don't do this kind of crappy setup. This is not how you do anything that deals with mains. I'm using a probe and loose wires. This is overall a pretty bad setup. Do not imitate this. Oh, it may blow up. There is many chances it will blow up. I'll just put it in a fan so it will still cool down somewhat. And I will put this in 10 amp mode. And now we will use my okay. Now I will turn on the power supply. Okay, fair. This is at 10 ohm load, so at 12 volts 10 ohms the current draw will be 1 amp 1 or 1.2 amp. V is equals to IR, I is equals to V by R, 12 by 10 1.2 amp, but this resistance won't exactly be same, so some resistance will be lost, so nearly same 1 amp. So now we will measure the voltage. So I will be using another multimeter to measure the voltage. So yeah, 12 volts. So this is supposed to be a 10 amp power supply, so we don't know how. We'll have to test it if it will still remain 12 volts, or there will be a voltage drop when we draw 10 amps around it, but I don't have a suitable load around it. In another video I will make an electronic load, and we will use that to test this power supply. So that's it. Please like and subscribe if you want, or at least just dislike if you want. Thank you and have a great day. Oh yeah, just I wanted to do another thing but I forgot, so I wanted to show you the how temperature, how hot this gets. So I'll be using this a K-type thermocouple and this multimeter to show you that how hot it gets. So right now this is dissipating 12 watts as a heater, so at 12 volts and 1 amp, so P is equals to Vi, so it's dissipating 1 watts, or P is equals to I square, or whatever, it's just dissipating 12 watts. So now I will measure the temperature. So now let me just see. So the room temperature is somewhere around 30. So now we will see how hot the temperature gets, of the resistor gets. This gets pretty hot actually. So anyways, it will keep climbing until it reach around 80 or 90, So that's the point, the resistor gets too hot. I wanted to show that